What I want to take a look at now are some of the finite element analysis capabilities within Autodesk Inventor. With my dishwasher at home, one of the things that I often experience is my son climbing on the door itself, allowing too much force maybe applied on these hinges or different components of the door assembly. This might be a concern for a designer or a thought process of a designer of how to build more of a quality component. Now, one of the things that maybe I want to analyze is the overall assembly. Autodesk Inventor in an integrated environment allows me to analyze full-blown assemblies as well as specific part components within my assembly. I'm going to go ahead and open up a specific component to show you and introduce you to some of the finite element capabilities within Autodesk's Inventor's interface. As we work inside the environment in this part model, we can simply switch to our stress analysis environment without ever leaving Autodesk Inventor. Autodesk Inventor allows us to generate a variety of different type of finite element analysis studies. Here we're simply going to run a static study on this component or on this hinge piece of geometry. We have the capabilities when working with Autodesk Inventor to integrate the materials that are defined within the Inventor part model into the stress analysis environment. If we haven't placed or if we want to change these materials, we can override these materials inside the interface. This makes it possible for us to create multiple studies with multiple different types of material components on the different parts within the assemblies that we're working with. We can also go into the environment and start to lay out how we want to hold or restrain different components within the model. So we can go through and fix some of the geometry, for example, and maybe I want to fix off these three different components or these three different pieces of surface geometry here. I also want to go in here and generate a force load on, let's say, a specific face. So I want to go ahead and analyze my son climbing up on this dishwasher unit. I want to apply a maximum force to the geometry. Maybe I want to figure out what that maximum force is. Within my assembly, I have capabilities of doing that as well, using some of the simulation tools within Autodesk Inventor and pass those forces directly into a part. I can also analyze or approximate those different components within this part environment as well, individually. I have the capabilities when working with the geometry to control what size mesh is being generated on the model. I also have capabilities to use local mesh control on the geometry to apply a series or a location of where I want maybe a more detailed mesh region on my component. I can also use the default mesh settings and mesh my component. We have capabilities of meshing this geometry as one of the fastest in the industry, above and beyond some of the capabilities that our competitive products have, and at much faster speed that our competitive products are offering. Once we've set up the different components for this geometry and different situations that we want to set up for this geometry, we can simply run the simulations that we've applied. So we've applied a series of forces and restraints to this component. We now want to take a further look at the overall geometry that we're working with. How does this component react? How are we going to visualize this component moving in a variety of landscapes with a variety of different types of materials? Very easily we can sit down and take a further look and understand how this component moves in relation to its original shape and original component that we're working with. We have the flexibility of generating a full-blown report so that we can send this off to customers, publish it on websites, or save this off with our original part files. Here we can see on this model, if we go to the factor of safety plot, that we have somewhat of a low factor of safety or low confidence on this component. So maybe we want to beef this up just a little bit, or we want to thicken up the model to ensure that we're at a higher factor of safety. So very easily we can go into the original model and generate some additional thickness to this geometry. So maybe we want to go ahead and thicken up the component a specified distance. So maybe we want to thicken this up, 0.1 inches in addition to the original thickness of the model. We can simply do that within Autodesk Inventor. And we can go back into the stress analysis environment once we've updated those components and we have the capability of automatically updating the different contexts. We also need to update the mesh geometry because we've changed some of the overall geometry on this model. Very easily we can go in, rerun this analysis within a matter of seconds, and start to evaluate our new results. Let's go ahead and take a look at the new factor of safety. Now we're within a range of reason that we want on this geometry, more in the 3.85. We can build this component, start manufacturing this component with confidence. Autodesk's Inventor stress analysis environment is one of the easiest to use in the industry, and also gives us the most confidence when working with finite element analysis results within Autodesk Inventor.